Hello. Um, so, welcome back. I know I'm posting this the day of, technically, the day of the assignments due, but people get busy and I try and upload many days before the assignment due dates or test days. But little backstory to this assignment, it pain in my ass. So yeah, I had to take, especially on this fucking question that we're about to do right now. This question, I had me questioning why I exist and why exactly I decided to pursue engineering. Not to that extent, but like this question was a bitch for me. Um, yeah, but without further ado, let's get into it. So this question in application is not that hard. The Where the bullshit starts is when you start taking the integral and you have these these 10 to the negative somethings all floating around, and depending on their placement it could fuck with you. So yeah. So limiting value of the population, basically like the max. The max that the population will get to. So what color do we want to do? Let's see, what do we got here? For this one, let's go in this color. Okay, not so bad. So, our population's modeled by dp dt equals p times 10 to the negative 2 minus 10 to the negative 5p. I will preface this video by saying this is going to be one of the longer ones because I'm going to approach the question in a way that would feel natural and do everything that would feel natural to like any other student doing it. And then I'm going to let you guys know when the fuckery begins. And by the fuckery beginning, as in when you may have that oh fuck moment in the middle of your question. And by all costs, do we want to avoid that? So, let me just get to the right page here. I am fucking tired. Today's been a pretty long day. Alright, so I'm just gonna start doing it naturally and then go with the rest. So we have this whole term right here. We're gonna go with dp over p times 10 to the negative 2 minus 10 to the negative 5p equals dt. I'm not gonna bother, with the little shit. Alright, so we got the integral. So I'm gonna break it up, and I found that this was what I like the most. So we got our right hand side, right? So that's just gonna be t plus c. Cool on that? Now the left hand side, left hand side's a bitch. So let's just start doing this. So we got the integral of this, okay, which is a over p plus b over 10 to the negative 2 minus 10 to the negative 5p. Okay, cool. So we're going to do our thing. So we're going to multiply across. So when I multiply by the p, I hate how I can't change the color of this pointer, but it's fine. When I multiply by the p, okay, so I'm going to get rid of the p here, get rid of the p here, I'm going to get a p up here, okay? When I multiply by this term right here, I'm going to get rid of this term. I'm going to just have the one on the on the left-hand side. Going to get rid of this term. Going to have a term, can I have that same term here? I'm going to get rid of here. So I'm going to have p here, and yeah, you'll see how it turns out. So usually you get, like, if you've done partial fraction integration by this point, you'll be pretty familiar with like what's happening here. Nothing crazy. So let's isolate for these coefficients. So for p equals 0, okay, 1 equals a times 10 to the negative 2 plus, and that's it, yeah, because the other one goes away. So I have a over 10 squared equals 1. And I'm going to have a equals 10 squared. You guys are gonna see where the bullshit is in a second, because this is already wrong, believe it or not. But we're just gonna keep going with it, and you'll see why it's a little bit fucked up in a second. So then I'm gonna go and I'm gonna split this up with this dotted line. I'm gonna split it up. Okay. There you go. Okay. So now for P equals, so this is like, and we're just going to rationalize this. If I got 1 over 10 squared, that's what this term is, right? Minus 1 over 10 to the 5 times P. I want P to equal 10 to the 3, just so it's 10 to the 3 over 10 to the 5 equals 10 squared. Okay? And then that'll be like 1 over 10 squared, 1 over 10 squared, and I get 0 for A. Okay? So that's just the backstory to that. So for P equals 10 cubed, then I'm going to get 1 equals B times 10 cubed. So now B equals 1 over 10 cubed. Okay? So, cool there. We have different things, so we're fine at that. But let's just keep going with it and see what we get. Okay? Oh my god. All right. So now that I have my coefficients, right? I'm gonna copy this so I don't have to rewrite it. And put this right here. Okay. And now this is equivalent to 10 squared, the integral of 10 squared over P plus 1 over 10 cubed. I'm just going to bring it on the outside just to make my life easier. And then, oh, fuck this, man. Okay. Sick. So we know here, and I'm just gonna do a little thing in the bottom. So what do we got here? We got 10 squared times ln P. That's we know that. 1 over 10 cubed. Now in the denominator here, right? When I did this, I defaulted to saying, you know what, this is just going to be ln. And we're going to slow down here for a second, because I'm going to see if I could reasonably solve this with like, kind of like what we know, okay? So first of all, if I keep this as positive here, after I integrate it, we're going to have multiplication. So we're going to have probably some type of ln function here, and it's going to be multiplied. We would rather have it subtracted just so we could have that kind of fraction in place. That's what we're used to. If you've done these questions before, you're familiar with that. You'll instinctively kind of lean towards that direction. If you don't, that's fine. But I'm just going to go about it in a way that I don't waste too much of your time exploring what's wrong and show you what is right. So what I'm going to do here, and I'm gonna make my changes in this color. So P times 10 to the negative 5 minus 10 to the negative 2. So nothing crazy, I just moved that out. And this is still dp. So I'm just going to focus on this term right now. So I have negative 1 over 10 cubed, okay? The integral of 1 over P over 10 to the 5 minus 1 over 10 to the 5, okay? Or sorry, over 10 squared. So what I could do is multiply this by 10 cubed. So I have 10 cubed in the numerator over 10 to the 5. Okay, we're still good. So this now becomes minus 1 over 10 cubed. And this is why I tell you, like, this fucking question is a little bit bullshit, because you fuck up at any step, the whole question's wrong. and this is 10 to the 5. All right, now we're back to the changing and moving around all the questions just to make space. Fuck it. Okay. All right, so now what we have here, minus 1 over 10 cubed. And I promised you guys with full solutions, so that is what I will deliver. Over p minus 10 cubed. Okay? So now we're cool. So now we have 1 over 10 squared, and you're going to really like that in a second. You'll see why. Over p minus 10 cubed. And we know that this is 1 over 10 squared because there's nothing next to this, so I don't have to make a u sub, times ln p minus 10 cubed. Cool. And we have a very important letter that we cannot forget. Actually, no, that was for the right-hand side, so we're good here. And then our full thing with the other one is 10 squared times ln p minus 10 squared times ln p minus 10 cubed. Reason why I said this question's a little bit of a bitch is because me, when I did it, at least, I just didn't bother rationalizing this. This portion right here, I didn't rationalize it. So just be very careful when you're doing that. I was also very tired at the time, but we're not gonna go too much into the details. So finishing off this left-hand side, factor that out. I'm gonna do a couple things here at once. So I'm factoring this 10 squared out, and because I have subtraction going on, I'm gonna use a log property, put this under this, right? We're dividing. So I would have ln of, use a big bracket, p over p minus 10 cubed. Okay, so this is my left-hand side, and I'm going to denote it as such. So this is my left-hand side. So when we put it all together, we're going to have this. And to be honest, guys, I wasn't expecting this to work for a try. The way I did it, to finally get the solution, I did some wacky-ass simplification really early on in the question. But don't worry about that too much. So our initial condition, if we go back up, is p at 0 equals 10. So let's denote that in a different color. P at 0 equals 10. Okay? So you'll see that if I plug 10 in here as p, I'm going to have a negative ln. So I want to get rid of that, ideally. Now this is where you got to pay attention with me really quick. So what I'm going to do is I'm going to get rid of this 10 squared. Okay? So I'm going to have ln of p over p minus 10 cubed equals 1 over 10 squared times t plus c. And that gets distributed out per the usual, but you'll see what I'm going to do here. So I'm going to bring this all up to a power of e, just to isolate. Now listen, this becomes e to the 1, and I'm going to expand it fully, t plus 1 over 10 squared times c. This is really e to the 1 over 10 squared t times e to the c over 10 squared. Whenever you see, funny. Whenever you see something like this, where you have e to the c, just let that motherfucker absorb that. So you'll have t over 10 squared. Cool? Just bring it out to multiply. That's just, notice that, remember it, get familiar with it, and love it. Give me 1 second. I also gotta get a sip of water. Okay. So continuing on, we're gonna have p, and let's just fast track this a little bit. So p minus 10 cubed, right? P equals p times, I'm just going to keep going with it, c to the t over 10 squared minus 10 cubed times c e to the t over 10 squared. Okay, and now I'm going to go back and use a different, I'm going to probably use something like this equation to solve for c, and you'll see why. Just because I'm isolating for p, right, I'm moving c around in a way that makes p the easiest to isolate for, so that inevitably makes it harder for me to solve for c. So why would I go back and do the work? Okay, now I'm going to do a couple things here in the same step. Going to bring this over, going to factor the p out. I'm going to have 1 minus this term, and then I'm going to bring it under here. Cool? Cool. Amazing. So, and I could have actually also just brought this over, and I'm going to do that actually. Because I don't want to factor out things and make my life complicated. So now, because I brought it over, right, now I have the c equals t over 10 squared minus 1, right? Okay, cool. So as it stands, we can make our lives in the numerator look a little bit easier at that. So let's factor out, and we're not really factoring it out, but let's just bring that on the outside. So we have 10 cubed times c over e to the t over 10 squared. Sorry, I said cube, my bad. C minus 1 over e to the t over 10 squared. Okay? Cancel these bad boys. We have 10 cubed over c minus 1 over e to the t over 10 squared. Okay? Times c. I'm going, because I did all that work to solve for c, and I don't want to go back up and like have to expand this out and, you know, redistribute this whole thing. Like, just go back to when I had it here. Actually, you know, even here works. This would be amazing right here. Okay, so let's just take this. And try and be conscious of what you're solving for and when you're solving for it. Oh, my bad. All right. Cool. So, with our initial condition, p at 0 equals 10, we got 10 here equals c times 10 minus 10 cubed. C equals 10 over 10, 1 minus 10 squared equals 1 over negative 99. Cool. Now we're going to plug that back into our original P question. Fuck's sakes, man. Every time I see this same thing. Like, I need one of y'all to give me like a better way to move around and write these things. I don't know, even if it's a different like notepad or like note taking app, then just let me know, because that's getting really annoying. So yeah, so now we got P equals 10 cubed times negative 1 over 99 times 1 over negative 1 over 99 minus 1 over e. Wow, okay, I don't know what that was. T over 10 squared. Okay? I'm going to factor out that negative. And you can slow down the video to see what I did there, but I just factored out the negative, and I'm going to cancel it right there. So, just even in this step, before I simplify anything, we know what our limiting value is. And you might ask, well, how do we know that? If this fucking thing draws a straight line. So how do we know already what our what our limiting value is. So in this function, p as a function of t, right? The max value I can get out of this is this, which is 1,000. If the denominator here is greater than 1, I get a number smaller than 1,000. Okay. And for any function, and like I was saying, how does this become bigger? Like, how do I get a number bigger than that? If this is less than 1. If I put, and t is my only variable here, if I put a value that's negative, right? I'm going to have this be negative in the denominator. The e comes up, okay? So I'm 1 over 99, just 1 over 99, right? Plus a really big number makes this whole thing with a larger denominator much smaller. So this is as the limit as t approaches negative infinity. As this approaches positive infinity, I get 1 over 99 plus 1 over a huge number, which is like 1 over infinity, which is 0, which is 1 over 99, okay? So then I multiply 1 over 99 times like this. I'm probably going to get something like 99 times this. Hold on. Let me make sure I'm limiting value. Maybe I'm just fucking trolling right now. A particular value. What is... Because I would really think the limiting value would be like this at like 0. Or like, what is it? What is the max? Yeah, I would say that it's what the max value approaches. That's what I would say. Okay, so let's just see. What is a limiting value? So it's a value that a function approaches. I would definitely not say that it's 1,000 times 99. Well, let's think here. If it's 1 over 99, and this, we're saying that it approaches infinity, right? We don't really count those values at infinity. So let's just say I have a really huge number here. You know what? I'm not your fucking professor. That's just the way it is. And yeah, because I actually can't. And if someone knows them, feel free to let me know. But like, I don't see how, like, if this approaches positive infinity, right? How this wouldn't just be like 1 over 99 plus something else, which, because it's in the denominator. And you know what we can do, right, that I think I did. All right, so this is what we can do. Let's just simplify a little bit more. So what I'll have is 1 plus 99. My bad. Et over 10 squared plus 99 over 99 times et over 10 squared equals 10 cubed times 99 et over 10 squared okay. So what you could say here is that for huge... Oh, I'm sorry, I'm a retard. Okay, so for huge values of t, if I put a really big value here, okay, then I will still have a huge value. This will be a huge value. But simultaneously, really these numbers don't matter at infinity. I don't know, guys. I don't really care that much. It's not that important. Yeah, if someone can explain to me why, then go ahead. But I actually don't think it's that more important. So long as you can get it in something as like this form, you'll be just fine. Okay. So now the next question after that, or the part B, because we already have part A. At what time, after how many months, will the population be equal to 1/7 of the limiting value in A? So 1/7. Okay, so they're basically saying P at P as a function of T equals the limiting value over 7. So 10 cubed over 7. Because that's my limiting value, right? Okay, and they're just asking for T at this point. So what I'm going to do here is I'm going to be like, okay, so I got 10 cubed over 7 equals this. Cool. First things first, cancel that, cancel this. Okay, so then I'm going to have ET over 10 squared plus 99 equals 99 ET over 10 squared times 7. Okay? And so what I'm going to then do is go like this. Minus 99 times 7 ET over 10 squared equals negative 99. Sure. Then factor this thing out. Squared. 1 minus 99 times 7 equals negative 99. Alright, so then if I do that, 1 minus 99 times 7, and then I'll get 99 over 692, I believe it was. Hold on. Wait a second, guys. I think I fucked up. I think the way I simplified it was wrong. Yeah, no, I did that right. And then like I feel like I fucked this up somewhere. Because, like, I shouldn't be getting this. Yeah. I shouldn't have 7 times that. Hold on a second, boys. Let me look at how I solved it before. Oh, no, I'm still right. But where'd this 99 come from? Guys, also taking it's 1 o'clock in the morning. What the heck? I'm gonna just say skip this part. And like, I'm gonna probably just have people skip this when I release it. Where the fuck did I write this fucking work for this? Dude. Alright, you guys gotta be real. I gotta be real with you that I also have like so much work, process work, that was like completely useless because so much of it was wrong. Oh, okay, this is not that bad. Oh, yeah, sorry. Okay, my bad. Yeah. I was about to say I fucking forgot something. Okay. So, yeah. All right. So you know when I plugged in C, way back here, I plugged in C and I got, like, what did I have before this, right? I had that over C, right? So I had this. I just forgot to keep the 1 over 99 here. That was it. Because then when you multiply everything, right, you're going to get times 99, okay? And then what that'll end up doing is, well, you could just not even do that. Just keep that like that. And then that way you won't have this here, okay? And then basically you multiply that up, you'll have, yeah, you won't have this 99 anymore, okay? So then you bring that over, you bring that part over, okay? And yeah, so now, so now you'll get e to the t over 10, sorry about that. 1 minus 7 equals negative 99. You're going to get 33 over 2. And then moving back out, just going to add a few more pages. If this thing starts bugging out again. All right. So. All right. So then, yeah. So now we get t equals 10 squared times ln 33 over 2. And that is the correct answer. So like even with the solutions present, I still had some difficulty with that. And that is partially because I'm tired and partially because I fucking hated that question. That question took so damn long for me. All right. Gompertz differential equation. This one's really important for whenever you see Gompertz, if they mention it or not. Usually they'll mention it if it's necessary, but if we try and do this regularly, and I'm gonna do this intentionally, unlike the other one where it like just so happened to work out for me, but this one we will run into an issue if we do it like this. So my differential equation, I'm gonna change the color because I'm not liking it. Let's go like this question. What should we do? There. dp by dt equals 6p 19 minus ln p. That's too sick. Okay. All right. So ln p, and then the initial condition equals 130. So dp over p 19 minus ln p, okay, equals dt times 6. Right hand side equals 6 dt plus c, right? And because it just absorbs the 6, and then we'll have the left hand side equals And you know, I'm gonna factor out a negative right there so that it becomes dp over, now you don't have to do this, but I'm just gonna do it just for the sake of ln p minus 19. Okay, so this is going to be a over negative p plus b over ln p minus 19. Okay, so 1 equals, when I multiply by the negative p, right, I'm going to have a times ln p minus 19 minus b times p. Okay, I want to solve for a, for p equals 0. Oh, what do you know? This is perfectly fine. This is the issue. I can't do that. And that's where I'm going to leave it off in terms of Gompertz. So, how do you approach this correctly? Whenever you see Gompertz, you're just going to instinctively know, and you're going to hear it from me, that you're going to have to do a U-sub. A very awesome, amazing U-sub that really makes the question good. So, come back here. And what are you going to make this U-sub for? You're going to make this U-sub for u equals ln p minus 19. Okay. du equals 1 over p dp. And so dp equals du times p. Okay. So, continuing on, now I'm going to have, and you can kind of just see this, I saw this in a video, but you know, you see how this is dp over 1p, right? You got that right there. I just find the substitution weird, so I'm not going to do that. But if I just continue on, I'm going to have du times p over negative p times u. Cancel that shit out. Negative the integral of 1 over u, and everything's chilling. Negative ln, and we'll sub u back in, ln p minus 19. Okay. So, let's go back to what we got. All right, so I got negative ln p minus 19 equals 6t plus c. And our initial condition was that p at 0 equals 130, right? I'm just going to kind of go a little forward towards where I left off in terms of this question. All right, I think right here is fine. Okay. All right. So, at this point, we're chilling, we're doing just fine. Now, if I shove in, I can't shove in ln p just yet. So what I'm going to do is I'm going to bring that negative over. So ln p minus 19 equals negative 6t minus c. And you know what I'll do? It's even better than that, is I'm going to go negative, I'm just going to go negative 6t, and I'm going to let that c absorb that negative as well. Okay? And honestly, whenever you multiply, like, you can't change that sign of the negative, right? So it stays positive. Whenever you ln it, you just know that, or whenever you raise it, your equation to a power of e, just know that it becomes a multiplication. You'll get used to it over time. So first time I raise it to a ln of e, to a power of e, sorry, I'm going to have ln p minus 19 equals c times e to the negative 6t. Cool. Still can't put my initial value in. So I'm going to have to, I'm sorry, but I just got to move this down quickly. Okay. And so next thing I'm going to have to do is raise it again. So I'm going to have p minus e to the 19. Yeah. Yeah. Yeah, right? hold on. So 5e to the ln p minus 19 equals c e to the 6t. Oh, that looks weird. That looks very weird. Why does that look weird? Hold on. Oh, I see. Okay. I knew that would look weird. I just had to check my notes. So you're going to have ln p equals c times e to the negative 6t plus 19. You'll have p equals c e to the negative why is it fucking... Yeah, no, okay, yeah, no, we're good. C times e to the negative 6t. Like, what if I just brought the whole... Oh, I'll just bring the whole thing up. E to the... Dude, why am I tripping? It's basically like this. E to the negative 6t plus 19. And I'm bringing this up, which equals c e to the 19 plus e to the negative 6t, right? Right? Or maybe no. Actually, yeah, hold on. Yeah, okay. So I'm going to guess that, when you do it like this, if you raise it twice, it can't do that. So you have to just raise the c with it. So you're going to have e to the c times e to the negative 6t plus 19. Okay. Just make sure, yeah. All right. So after that, we're going to take one of our previous steps where we can sub in to... Fuck. What was our initial condition? Yeah. Yeah, so none of these earlier ones we can sub into. So what we'll do then is just use... sorry. We'll just use... oh, wait, no, sorry. I'm not shoving it in for t. So what we could do here is... just use this one. We're just going to use this one. And sorry, I'm going to get a little bit slower because I'm getting tired right now, but bear with me. So to solve for c, what we're going to do is going to do ln 130 minus 19 equals c times e to the negative 6 times 0. This becomes 1, so c equals ln 130 minus 19. So then what I'll get as my p, is p as a function of t equals e to the ln 130 minus 19 over e to the 6t plus 19. And our limiting value here, because that's this is our value in with c, right? So what is our limiting value? Basically what we're asking ourselves here is like, what is the maximum value that this could be, sort of say. And actually, wait, no. Limiting value, and this works. Limiting value is as t approaches infinity, whatever that value is, okay? I think that's what the definition would be. So on this last question, and I'm going to really hammer this home. So on this last question, where do we find our initial value? So, okay, so we found it here, right? And then we did a little bit of simplification, and we basically got to... That shouldn't be there. And then I think everything else is good. Okay, so as t approaches infinity... Oh, perfect. For this question, for this right here, as t approaches infinity, we don't care about anything else. Okay, as t approaches infinity, okay, you're going to have a huge number right here, okay? And you're going to have a huge number being multiplied by that equation, okay? But... Oh my God. But I think these two will just cancel themselves out. And at infinity, this won't really matter. I can't imagine on the last one why we really define our limiting value as that. But over here, it's much clearer to see that this will go until infinity. You're going to have some number, a small number at that, over a really large number. So this will be 0, okay? And you're just going to have your limiting value will be equal to e to the 19, okay? And then they ask what is the value when the population at t equals 3, which is perfectly easy. So I'll have p at 3 equals e to the ln 130 minus 19 over e to the 18 plus 19. Cool. Okay, not so bad. Let's keep going to question 8. All right. So, generally for these questions, there's a big formula, not a big formula, but an important one that you have to know, which is dx by dt. I remember it. It is dx by dt equals Rn minus R out. I'm just going to flip the page on my notebook. Okay. Rn minus R out. So, Rn is easy. Rn equals the salt concentration times the flow rate in. What's my salt concentration? 12 grams of salt per liter. So 12 grams per liter times the flow rate in, which is 6 liters per minute, cancels. We have 72 grams per minute rate in. All right, now the rate out is what's important. X as a function of t over. This number is 130. This is the amount of water in the tank. So rate out plus A at t. And this value right here, okay, is the net added / removed after t minutes. So like that value is either positive or negative. It's rate out in this case, but like we could get a question being like, okay, you have this value coming in. You have a salt concentration coming in at X amount. We are also manually adding at X amount. So you'd consider that A at t. Okay, so an X at t, as we know, is the total amount of mixed solution as a value of t. Okay? Now, given that, and given this very important equation, we are going to sub in. But before we do that, we got to find our a at t. And our a at t equals the integral from 0 to t of Rn minus Rout. Now this is just the volume, 0 to t. In our question, we have pumped into 6 liters per minute, pumped out 4 liters per minute. 6 minus 4, 2t. Okay. So, with that being said, we have a at t equals 2t, and we can just now sub in. So, our dx by dt equals the rate in, which is just the amount, so 6 liters, minus x at t over 130 plus 2t. Now, dx by dt plus x at t over 130 plus 2t. And let's not forget a very, very careful thing for a rate out, being that this is also multiplied by the flow rate out. So same thing, but the salt concentration is what's different. Okay? So the salt concentration, x at t, is what's different. Okay? So, and our rate out would be 4 equals 6. Oh, sorry. And this value, this is not just the volume. We used that in a previous one. This is the actual rate, which is our rate with respect to our salt concentration. So, what we calculated there. So this equals 72. Okay. This may look very familiar. We have a differential equation, a separable one at that, and we're going to use our integrating factor. So I at x equals e to the integral of p at x dx equals e to the integral of 4 times 1 over 130 plus 2t. We see that there's a number next to that. So we're going to make a quick u sub. Now listen, I've done this ahead of time. You can just, you're going to u sub this, and it's going to come out to ln. For time's sake, we know that this is 2 times ln 130 plus 2t. Okay? You could do that yourself, but yeah. Now, continuing on, the question's asking us, okay, and a lot of the work that I'm doing right now helps in the next question, but the question's asking us, find an expression for the amount of water in the tank after t minutes. Okay. So that's this right here. After t minutes, right, we have the total amount of water that was in the tank plus or minus what's being added or removed. Okay? That's this right here. The second part of the question is asking us, and the reason why I continue to do the integrating factor and all that stuff is because it's going to help us at question 8, and you'll see why, because it's related. Now, B asks us, let x at t be the amount of salt in the tank after t minutes. What's the following one? Okay. We already have this if we're smart enough. And we know that it's F, but why? I'm gonna make you guys look fucking stupid right now. Oh, I didn't copy my thing. I look stupid now. But yeah, you guys have eyes. You can see it and see that that's it. But still, we have our integrating factor, I at x, okay? And we are going to partially move on to question 9. It is related though, so we could think of this as a section C. But they're asking us, in problem 7, problem 7, the size of the tank was not given. Now suppose it has an open top with a total capacity of 182 liters. How much salt? Okay. In question A, we determine an expression for the amount of water in the tank after t minutes, which is this. Okay. So to solve question 9, the volume of the tank is equal to 130 plus 2t. And we're saying that the total volume is equal to 182 liters. So we want the salt in grams instant that begins to overflow. So the instant that it begins to overflow would be the time that it reaches 182. Correct? So 2t equals 52. T equals 26. Perfect. And now we just have to solve for x at t, which is the amount of salt relative to the tank. And we already have our integrating factor. So continuing on, we know that we could bring this fucking 2 up. I'm going to start cussing because this shit's pissing me off and I want to sleep. So, oh, and also this was to a power of e, right? So we have to bring this down. So officially, our integrating factor equals 132 plus 2t squared. Okay. 130 plus 2t squared times x at t equals 130 plus 2t squared times 72. Boom. This is going to equal 72. We sub our u in. If we sub our u in, right? I have another page where I did that. We sub our u in as u equals 130. U equals 130 plus 2t. We're going to get u squared, okay? And I'm not going to keep that there because I can keep it there and just move this down. Last question is probably my favorite one. Okay. So with this being said, okay, I'm going to just highlight this just so you guys don't get confused. So with that being said, then we're going to have 72 times u squared, which is just u cubed over 3. 72 divided by 3, guys. Let's see who could do the math faster. It's probably got to be like 24, right? 24 times 3, yeah, 72. Okay. So we got 24 times, fuck it, let's just keep going. Equals 2 dt, so dt equals 1 over 2 du. So this equals then 130 plus 2t cubed over 2 equals 12 times 130 plus 2t cubed plus c. Okay, amazing, guys. X at t equals 120 times 130. Oh, whoa. 112 times 130 plus 2t cubed plus c over 130 plus 2t squared. And the reason why I did that is because this goes down to 1, and this finally equals 12 times 130 plus 2t plus, and then this fucking thing. Alright. Sick. Cool stuff. We need C. And we know, based off the question, not this one, but the original one, it initially can, let's read, different color. In which 21 grams of salt is dissolved. It's already dissolved in there. Already there, guys. So, x at 0 equals 21. Perfect? Okay. Which means that we could do a very, very quick solution, being that 21 equals 12 times a 130 plus c over 130 squared. Okay? 21 minus 12 times 130 times 130 squared equals c. Amazing. And now we want, okay, we have now x as a function of t equals, and I probably should make my thing wider, but x as a function of t equals this. And now we know what c is. So now we just put this where this was. Okay? And we calculate x at the value that we got up here. Sorry, the value that we got, where'd I put it? The value that we got when we saw that this is exactly the instant that it overflows at 26. 26 equals, and you will get, if you work it out, 1,398.00.80. Okay. Amazing. This question I like. This is probably my favorite question of the entire stupid child's math. Alright. Let me get a sip of water. We'll be done this, and we could probably do some test review in coming videos. Alright. So let me get to the other page. Alright. Read the question carefully. Initially, reading 21 degrees. Preheated to a constant temperature. A glass window, blah, blah, blah. 30 degrees after 36 seconds. 32 degrees after 72 seconds. How hot is the oven? Okay. We're going to finish this off with orange. Okay. For these questions, you must know this formula. Equals K times T as the temperature as a function of time minus the constant temperature. This is the constant temperature, the ambient temperature. This is what's important to us. We are solving for Tm. Okay? And we know that T at 0 equals 21 degrees. T at 36 equals 30 degrees. And T at 72 equals 32 degrees. Cool. Okay. Now, let's just put some things in and see what we get. Okay. So I want my T on one side. Okay. So I'm going to get dt over T minus Tm equals K times dt. Okay. So I'm going to get K times T plus C, because it just absorbs it, right? And I'm going to take the integral of that side, and I took the integral of this side already. Okay? And I know that the steps are a little bit messed up, so let me fix that. I hate when it does that. Okay. Okay. Put that over here. So now, I'm going to get ln of T minus Tm. I don't know why I moved it so far. Okay? Now in this case, okay, when I have, what if I just propose, right? And it just think about this with me. Is the question related to the thermometer getting hotter or colder. Because if it was getting colder, right, what it would have to mean is that T is greater than Tm. This is what it would be for cooling, okay? And this is why I kind of like this question, because it makes you think a little bit. But since it's heating up, Tm must be greater than T. Why? Why am I enforcing this rule specifically? Because not only does it logically make sense, just relative to what I'm saying here, but also that this is a ln. This function is ln. If Tm was greater than T, I'd have negative ln number, like ln a negative number. I can't do that. I can't. Right? So, continuing on, what we're going to do is this. Ln Tm minus T equals Kt plus C. And I can sub in any value to solve for C right now. I can sub in T at 0 equals 21. And have ln Tm minus T, which is 21, equals C. Right? Because T, this is not capital T. This is also not capital T. Where else did I write it? Okay. This is just small t. This is small t. Okay? Perfect. Now, given this, okay, I have two other points that I need to use. I have ln, okay, and you're going to see where I'm going with this. Just follow along. I have ln of Tm minus 30 equals 36 times K plus C. Okay? And remember that 36 got distributed here, so I could just, really what I could just do is divide. And sorry, I'll just plug in C right now, right? Ln of Tm minus 21. Okay? So, what I'm going to do here is ln of Tm minus 30 minus ln of Tm minus 21 equals 36K. 36K. Okay, I'm going to do a couple things here. I'm going to have ln Tm minus 30 over Tm minus 21, 1 over 36 equals K. Isolated for K. Now, what I'll have for this last point, just based off this, is going to have 1 over 72 times, and you could follow the same steps if you need to, but fucking pasting image, man. Tm minus 32 over Tm minus 21 equals K. I'm going to set them equal to each other. Okay? So, grab this. Okay? Grab this. Okay? Now, boom, boom, 2. 2. Just instantly. Okay? So, now I have ln of Tm minus 32 over Tm minus 21 equals 2 times ln of Tm minus 30 over Tm minus 21. I want to bring this up to E, so I can start solving for Tm, my constant ambient temperature, which is what I'm looking for the oven. So I'll have Tm minus 30 over Tm minus 21 squared. If it's squared, I could also just do this. Okay? And I've already brought it to ln up until this point, right? So minus 32 over Tm minus 21. Now, I multiply this up here, okay? Stay with me. 32 times Tm minus 21 equals Tm minus 30 squared. Okay? Let's do this really quickly. Tm squared minus double the product of the two, 60 Tm plus 90 okay? Tm squared minus 32 times Tm, boom, minus 21 times Tm plus 32 times 21, okay? Cancel this, no matter what, okay? Now, I'll have negative 53 Tm plus 32 times 21 here, minus 60 Tm plus 90 squared. Sorry. Okay? Gonna bring this over. Okay? I'm gonna have 7 Tm equals 90 squared. Bring this over. Minus 32 times 21. Calculate that real quick. Oh, fuck. Wait, hold on. No, this is just 30 squared. What am I talking about? I was gonna say, I'm like, that's way too big. 30 squared. Okay? Okay, so 30 squared minus 32 times 21. So I get 7 Tm equals 228. Tm equals 228 over 7 equals approximately 32.57 degrees Celsius. And that is Child's Math Assignment 2. So yeah, let me know if I need to go slower or faster. I'm gonna timestamp like the times when I was thinking when I upload this. It's 2 o'clock in the morning, and tomorrow we'll see what happens. Tomorrow I probably won't be recording a video, but I will definitely get MATLAB out. Always, at least, you know, I'll give you like maybe 16 hours. I'll always try to have a video out at least 16 hours before the assignment's due. At the bare minimum, like if I get really busy. But yeah, thanks for tagging along, and I'll